So if you're, say, an enterprise or a big university campus,
Yeah.
you're probably stuck in this constant battle, right?
Yeah.
Old legacy cables versus the new IP stuff.
And that's where we're going today. We're doing a deep dive on a piece of gear that tries to solve that exact problem. It's the Thor Broadcast H-8DVBS-IP.
Exactly. It's this piece of head-end equipment designed to stop that friction. It's all about bridging those traditional RF streams, satellite cable with a modern high-speed LAN.
It's a gateway, really. At its heart, it's a transmodulator. It can take up to 8 different RF signals and, well, translate them into these really versatile IP streams.
And that's the thing that seems to be the architectural breakthrough here, the sheer flexibility of the tuners.
It's absolute flexibility. This specific model we're talking about has 8 satellite S2 tuners, but the core platform can handle, well, pretty much any global standard you throw at it.
Like ATSC or cable QAM.
ATSC, QAM, DVB-T, ISDBT, all of it. So you get this instant compatibility without having to spend months, deploying totally new infrastructure.
What really caught my eye was that it's not just RF to IP. It can also do RF to RF at the same time.
Yes, that's a huge utility game.
So you could take, for example, an over-the-air DVB-T signal and convert it to IP for your network.
And also output it as a local QAM channel simultaneously.
Which means for an existing headend, you could bring in, say, 8 free-to-air channels, mix them around.
And output them as 8 new QAM channels right alongside your IP stream. It makes adding new content so much easier.
Okay, so the conversion power is clear. Let's talk about what happens when those streams actually hit the network. The sources say they come out as SPTS or MPTS.
Right, and that's a great question about efficiency.
So why would an operator choose one over the other?
Well, SPTS single program transport stream is simple. One stream is one channel. It's easy to manage. But MPTS, the multi-program stream, that's where you save a ton of bandwidth.
I'm bundling them.
Exactly. You bundle multiple channels into a single stream. If you're pushing dozens of programs over a network with limited capacity, that's a huge deal.
And it's not just about IP, is it? I saw it as 2 ASI inputs as well.
It does, which is serious synthesis power. For anyone who doesn't know, ASI is like the professional umbilical cord for moving streams between broadcast gear. So this box also works as a dual ASI to IP gateway.
And what about the quality? Is there any loss in all this conversion?
According to the specs, no. We're looking at perfect full HD, no loss. It supports both MPEG-2 and the more modern MPEG-4 H.264 codecs.
It was a pretty high bitrate too.
Up to 19.5 megabits per second, yeah.
And speed is critical for anything live. The sources mentioned low latency is available.
It is, and it's seriously low. We're talking 10 to 20 milliseconds.
Wow, so that's basically real time. There's no perceptible lag.
In a control room, that's everything. It's
Yeah.
the difference between seeing it as it happens and, seeing it at a frustrating moment later.
Okay, so it's fast. How do you manage it all?
That's the easy part. It's all done through full IP control, just using a standard web browser. And on the compliance side, it supports things like closed captions, which is essential.
Let's talk about actually deploying this. It's a rack-mountable box, but what are we looking at size-wise?
It's pretty compact, 19 by 9 by 3 inches. And it weighs just 6 pounds.
So you could fit quite a few in a standard rack space without much trouble.
You really can. And they only draw about 20 watts of power, which is another critical detail. It means less heat in your already crowded racks.
So to kind of wrap things up, this is really a device that's built to simplify the chaos. It takes all these different sources.
Terrestrial, cable, satellite, anything.
And it standardizes them onto a single manageable IP stream.
Right. And, if we connect that to the bigger picture, it raises a really profound question. If a tool like this can instantly unify pretty much any global modulation standard onto one local network, how quickly does that make things like legacy coax distribution obsolete? What happens to TV for huge institutions when the barrier to unifying everything gets this low?